Okay, next we're going to think about the electrons. I've talked before about the idea that glucose is full of electrons. It's full of high energy electrons, and that's where all the energy is in our glucose molecule. So we can load up our glucose molecule with electrons. And then as we go through this process, what we're doing is we are stripping away these electrons. And that occurs over here in our electron carriers. NAD comes in, picks up 2 of those electrons. NAD comes in, picks up 2 electrons. So we have a whole bunch of electrons in our glucose. We've had a couple of them stripped away over here, a couple stripped away over here. We still have a good number of electrons then available in our pyruvic acid. So we need to strip more electrons. NAD comes in, strips away electrons, leaving these electrons in the acetyl-CoA. NAD comes in, our acetyl-CoA enters the tricarboxylic acid cycle. NADH strips away 2 more electrons. FADH2 strips away 2 more electrons. And we are left with all the electrons being stripped through this process. So we are chipping away and chipping away and chipping away and chipping away at the electrons. We are extracting all of those energetic electrons throughout our process. And when we have an electron transport chain available, and when we have terminal electron acceptors, we are going to send all of our electron carriers to our electron transport chain. So we're stripping away the electrons, putting them into electron carriers, and that's exactly what our electron carriers are doing. They are carrying the electrons from the reactions to our electron transport chain. And at our electron transport chain, this is where we're going to make most of our ATP. We're going to see a chemical reaction where we take ADP, using the power of all these electrons to generate ATPs. So once we make 2 ATPs over here and a couple of ATPs over here we can make around 34 ATPs. So by far and away most of the ATPs that you're using to run your biochemistry come from the electron transport chain.